For number 7, they want us to simplify the expression, and you might be able to just look at this and realize that these are almost identical. There's just a slight problem with the signs. If this was a positive 12y and a negative 12x, it would be exactly the same as the numerator, and you'd be able to cancel. But in this case, again, that might be kind of hard to see, so I'll give you an example that's a little easier to see. If you had negative 5 plus x, and let's say negative x plus 5, if you had this rational expression, you might be able to tell pretty readily that these are almost identical. This is a good place to factor out a negative 1, and I'm going to factor a negative 1 out of the numerator. It doesn't matter whether you factor it out of the numerator or the denominator. Alright, so if I do that, if I'm going to factor something out, I have to be ready to put it back in. So negative 5 divided by negative 1 would give us a positive 5. Okay? And positive x divided by a negative 1 would give us negative x. Alright, so that would be our numerator. And again, you can check it. If you send your negative 1 back in, you'll be right back where you started. I haven't changed the value of the numerator. I've just made it look different. And our denominator, what do you say I put the negative x in the second position and the positive 5 in front? I don't really have to do that, but at least that makes it look exactly the same. And this 5 minus x is being multiplied. It's grouped together in the parentheses. This 5 minus x is being added and subtracted, but it's grouped together by this grouping symbol. So I can say 5 minus x goes into 5 minus x one time, and the answer would simply be a negative 1. Okay? So I'm basically going to do the same thing over here on number 7. I'm going to factor a negative 1 out of the numerator. So that means I'm going to divide by negative 1 and divide by negative 1. When I do that, I'll get a positive 12x and a negative 12y. Oh, I shouldn't have used a 1. Alright, let's rearrange this. And, well, it doesn't matter. I'm going to put this negative 12y in the second position, just because it's easier to write that way. And the positive 12x I'll put in front. As long as you keep the sign with a term, you're allowed to move it around. And again, this 12x minus 12y is grouped together in parentheses, and this 12x minus 12y is grouped together by this single division bar. So these are common factors, and I can cancel them. This goes into itself one time, so we're left with just a negative 1. By the way, I'll just mention this is the answer to number 7. Okay, it is a negative 1. But you could have also factored out the GCF, which would be a negative 12. You would get the same result. So let me just show that quickly. So if I had said, well, I'm going to factor out negative 12 from each term in the numerator, that would mean I'm going to divide by negative 12 and divide by negative 12. Okay. When I do that, I would be left with a positive x and a negative y. Okay. And in the denominator, I could just factor out a 12. I wouldn't want to factor out a negative 12, because then I'll just have my signs causing the same trouble they were initially. Okay. So this is saying I'm going to divide by 12 and divide by 12. Okay. So negative 12y divided by 12 is negative y. I'll put my negative y over here. And positive 12x divided by 12 is simply x. All right. Now notice x minus y goes into x minus y once, and 12 goes into a negative 12 negative 1 times. So you would still be left with a negative 1 even if you proceeded in that mode. All right, that's number 7. We'll take a look at number 11. What do they have? Find the product and simplify. Okay. Number 11 might look a little strange because you only have one rational expression, and then y to the 12th is not a fraction. Anytime you have something that you wish was a fraction, you can simply put it over a 1, because that doesn't change the value, it just changes the way it looks. Okay? So I have y to the 12th over 1 times this rational expression. Notice nothing here is being added or subtracted, so we can cancel common terms. And let's go ahead and do that. Actually, maybe I'll rewrite it just so it's a little bigger and easier to see what I'm canceling. Or better yet, I could combine them. If you can understand canceling from right here, you can go to it. You would cancel y to the 4th, and this would become y to the 8th, but you'd still end up having to combine it with y to the 1st. So I'll just put it all together. We've got 8x to the 8th, y to the 1 times y to the 12 is y to the 13. That's our numerator. And in the denominator, we simply have exactly what we have here. 64 x to the 8th, y to the 4th. Might be a little easier to see what we're up to here. So for the coefficients here, 8 goes into 8 once, 8 goes into 64 8 times, and then you have x to the 8th over x to the 8th, so x to the 8th goes into itself once, x to the 8th goes into itself once, and you have y to the 13th over y to the 4th. Basically the smaller one gets used up. You subtract 4 from 13, you're left with 9. So all that's left standing here is y to the 9 over 8. So that would be our answer. Takes care of 11. We'll also tackle number 12 here. Actually, I think I'll refer to 11 as I do this. Notice in number 11, nothing was being added or subtracted, so we were allowed to cancel directly. But in number 12, as soon as you have terms being added or subtracted, they're not factors, so you can't cancel them. Okay? You're only allowed to cancel common factors. So at this point, you're going to refer to this list of rules, and again, I'm not going to cover them all here, but basically we've gone over this quite a bit. And the first thing is always look for a GCF. So in our numerator here, we have a GCF of 2. We'll be factoring that out. And in our denominator over here, we have a GCF of P. So we'll be factoring that out. Okay. This is over a 7. I'll keep the multiplication dot, but I could really just connect this and make it one big fraction bar. And then 3p to the seconds up here. Alright, that didn't go anywhere. And when we factor 2 out of each term, we're left with p minus 1. And then down here, again, you're left with factor p out of each term. You're left with p minus 1. And you can cancel common factors. Okay? This p minus 1 is contained within parentheses. It's now being multiplied, so it's a factor. Same as with this one up here. So you can cancel common factors. Goes into itself once. You can also say p goes into p once, and you subtract 1 from 2, so you're left with p to the first. And all that's left standing here is 2 times 3 is 6p over 7. Okay, so that one cleaned up quite a bit. And let's see, we will also take a look at number 15. '15 might look a little bit intimidating to start out, but they're asking you to find the area of this rectangle. And what's the formula for area of a rectangle? Area is equal to length times width. Okay, so it's a multiplication. And the length is x plus 9 over 2x to the third. The width is 7x over x squared minus 81. I grant you that might look strange, but it's simply length times width. Okay, so following this formula, we'll have x plus 9 over 2x cubed times, and then 7x over x squared minus 81. Okay, and now it looks just like, or at least very similar to the problem we were just solving. Okay, and we'll focus on this now. You're just going to see if you can factor anything, factor out the GCF, etc. Whatever we can do. So here and here, you're not going to be able to change anything. The only thing you'll be able to change is this denominator. Is there a GCF? No. Do you have two terms? Yes. Is it a difference of squares? Yes. Okay. So x squared minus 81 can be written, square root of x squared is x, square root of 81 is 9, and you just have to remember that the signs have to alternate. So this is the factored form of that binomial. Alright, so that came down. Everything else is just as it was. 7x is in your numerator. And you have x plus 9 over 2x cubed. These are being multiplied. And now you can cancel any common factors. All right, you have a x plus 9 and x plus 9. That goes in there one time. You have x will cancel out one of these, so you'll be left with x squared in the denominator. Well, 2x squared. And that's everything that'll cancel. So let's just record what's left standing. We have 7 over 2x squared and x minus 9. Okay, the units are in feet. And this might seem strange, but area is written in terms of units squared. So the area of the given rectangle is 7 over 2x squared times the quantity x minus 9 feet squared. That takes care of 15. And let's see, we can also do 17 here. We can get our division out of the way. Let me zoom in a little so maybe you can see that division sign a little better. Okay, this is problem 17. It's 2x squared over 5 divided by x to the third. Shuffling here. There we go. Much better. Alright. When you divide by a fraction, you have to take the reciprocal and multiply. So this gives us 2x squared over 5 times 25 over x to the third. Nothing here is being added or subtracted, so you are allowed to cancel. And oops, meant for a colored pen here. You have x squared, x to the third, so both of these x's cancel out. You'll just be left with x to the first in the denominator here. And 5 goes into 5 once, 5 goes into 25 5 times. So now we just have to record what's left standing, and we've got 2 times 5 is 10 over x. Okay, so that would be our answer for number 17. And we will also take a look at number 19. Okay, and again, this one might look unusual because this first term is not written as a fraction. So if you have something you wish was a fraction, you put it over a 1 and you have a fraction. Okay, I'm going to have to take this second term here, the rational expression, and flip it and multiply because of this division sign. So that's going to give us x plus 8 over 1 times 12 minus x over x squared minus 20x plus 96. And I got a feeling we'll have to zoom out a little bit here. Okay. One more. If you have terms being added or subtracted, you can't just cancel. I definitely can't cancel this x with this x. This is being subtracted. If I had a 12 minus x in the denominator that was being multiplied, then I'd be able to cancel. So we're going to have to see, is there a GCF anywhere? Nope. But down here, GCF, no. 2 terms, no. 3 terms, yes. So we're going to try to factor this denominator. Alright. So you just grab your 96. Basically, I'm going to try to get this denominator into two sets of parentheses. So you look at your 96 and say, can we find a sum of negative 20? That means both terms must be negative. So 196, 2 and 45, 48, 3. I could speed this up, but I'll just do each term. Slide this over some. 3 goes in there 32 times. 4 goes in 24. And still going to be a little too big. 5 won't work. 6 goes in. Half of 32 is 15, 16. Darn it. 7 won't work. 8 goes in. I run off paper. Half of 24 is 12. And we finally have Negative 8, negative 12 will give us our negative 20. So this will be x minus 8, x minus 12, and everything else. Oh, they are being sneaky. Well, let me see, x plus 8. I'm not going to be able to change that at all. So I have x plus 8 over 1 times. But notice here, before I bring this 12 minus x down, it's almost identical to the denominator. There's just one little hitch. I need a negative 12 and a positive x. So what should we do? Factor out a negative 1. All right. So if I factor out a negative 1, that means it's going to be 12 divided by negative 1 would be a negative 12. So I'm going to put it here, negative 12. And negative x divided by a negative 1 would be a positive x. Okay? Now, this x minus 12 is a factor. It's being multiplied. Okay, as is this x minus 12. So that goes into itself once. We cannot cancel here. And we can't, if we factor out a negative here, we'll have a negative x and a positive 8. We don't have a negative x up there. So we're not going to be able to clean this up. Let me zoom out a little more and write the final answer. So the result of all our hard work is x plus 8. Ooh, I have a negative over here, so don't forget that. Negative x plus 8 over x minus 8. And again, if I send this negative in, I'll get a negative x and a negative 8. Whoops, sorry there, folks. Let me just zoom out one more. This negative 1, I've just written it as a negative sign. If you want to put a 1 there, you're welcome to. If I send it in, I'll have two negative terms, and it won't match what's in the denominator. So this is as much as I can simplify this expression.